just wait another few seconds and then we'll get started. Okay, my name's Ulrich Roxburgh. I run a small company called Services 2, which specialises in architectural consultancy, specifically solution architecture, and my primary area of focus is around integration architectures. So I've worked with a lot of big corporates around Australasia, in particular Commonwealth Bank and ASB and companies like that. This talk is about some work that I've been doing over a few years around implementing specific systems inside large enterprises. So the kind of work that I did at Commonwealth Bank and so on. This follows on from a talk that was given yesterday by Paolo Rocha, who talked about capabilities. So Paolo's talk talked about identifying what do we want to build. And my talk is a talk based on how are we going to build it? What's it going to look like? So a few years back, I co-authored a book on integration patterns with a bunch of guys from up at Corp and with a few sort of industry experts in that area. And some of this talk has been derived from that book and some's been derived from some engagements that I have done in Auckland and over in Sydney. I've kept names out of it to protect the innocent. Anyway, so the agenda for today's talk, firstly, what are design patterns and how do we use them? And then how do we actually build some capabilities using patterns? Obviously, in the space of an hour, I can only talk about a limited number of capabilities, but we'll try and cover them as thoroughly as possible. So what are patterns? Well, patterns occur everywhere. You use patterns all the time without even knowing. I was watching the documentary series on TV a few months back now, Wild China, and they showed the rice terraces, and you know they come out with these big water buffalo, and they plant, you know, they plough these terraces and then plant rice in them, and it's very intensive, very labour intensive, and it's very important for the local people that, you know, they get a good crop. Obviously, you don't go to that level of setting up irrigation systems and maximising the use of the landscape if the crop isn't very, very important. The problem they have is deciding when to plant. You plant too early and a late frost comes and basically burns all your crops. You plant too late and you don't maximise the potential for growth and for harvest and maximise the number of the amount of rice that you get. So the farmers there have a pretty simple way of figuring it out. It's a complex system. The way they understand that system is that when the swallows arrive, that's a good time to plant. Apart from the fact that they're using an architect who's a bird brain, well, hey, you know, it's pretty clever. It's a pretty simple way to go and do and look at a very complex system. We also look at patterns in sport. So patterns allow a team of players to work in a coordinated way. So these are all atomic units. They're all, you know, individually motivated, but a pattern allows them to work in a coordinated way to achieve an end goal. The other thing that patterns in sport highlight is patterns also provide a language that you can talk to other people about that can explain a complex situation in a very succinct way. So think about American gridiron, and we've all seen, I know we're all Kiwis and you know we think about a different kind of sport, but you think about the American gridiron you've seen and they're down in the huddle and they call out a bunch of numbers. Those numbers are a code for a pattern that that team knows, and it tells each individual what his job is when he goes ahead to to implement that play. So as well as providing a way of solving a problem, patterns also can provide a vocabulary, a language that people can talk about something in a common way. There's also patterns in business, and I put the whole slide up there, but really what I want to talk about here is that this is partly why we're building these architectures in enterprises. Basically, 10, 15 years ago, companies like the banks and the insurance companies basically ran out of customers, essentially. New Zealand's got a set number of people, and those people were distributed across the 4 or 5 major trading banks, for example. Now, your shareholders want you to make more money. So what do you, as the person running the bank, do? You can sit there and cut costs and produce better services, but that's a pretty finite end game. The other banks will immediately start to do the same thing, and you cut costs too much, and you're not going to make any more money. You might attract a few more customers, but in the end, when the other banks compete using the same things that you do, what happens? Basically, you end up with roughly the same ratio as before. So one of the ways that banks and lots of other businesses tried to make more money was to basically buy up other financial services. So we had banks that bought insurance companies, and insurance companies that bought banks, presumably. We had banks that bought other banks. And the result of that was, of course, that they got more customers. And so you would have been, if you were in New Zealand, like 10, 15 years ago, you might well have gone up to your teller at your local bank, and they turned around and said, can we interest you in life insurance as well? I was actually only there to draw some money out of my account, but they're asking me questions about life insurance. The implications of this on the IT department, of course, was profound. No matter how cohesive and how balanced a vision the CIO had in that organisation, and how careful he was to craft the kinds of systems that he was using for CRM, for financials, for his mainframe, for his transactions. The fact is that somebody outside of his control then went and bought an insurance company that had another set of CRM, another set of another set of mainframe technologies, another set of financial technology, and you're now in the position where you have to support all of that stuff. And now you need to integrate and try and bring those things together. And my first example that we're going to be designing is basically around exactly that scenario. So let's get on to patterns in terms of IT. So patterns are a mind-sized chunk of information. If I talk about, say, loan provisioning, apart from 1 or 2 people that have been in the industry a long time, that's a large, complex problem for a bank or an insurance company to manage. And so we have to break it up into mind-sized chunks that one person can comprehend and understand. And a pattern is exactly that. Probably the most important thing that a pattern does is it shows a known good solution in a specific context. So, for example, if I have multiple different kinds of messages that need to be routed multiple different kinds of places, a message broker or a message bus pattern is a known good solution for that scenario. Patterns also describe relationships. So when you look at object-oriented programming, a single object or a single class on its own doesn't mean much. What means something is when you put those classes or those objects into an application and they have relationships. They have inheritance relationships, they have users relationships, that kind of thing. Patterns provide reusable design elements, like an architect in a building or an architect who's designing cars would use reusable design elements. We can use patterns exactly the same way. And as I've already said, they're a common vocabulary about for talking about a solution. The other important thing to stress is they're not an implementation. They don't say you must use Microsoft technology, you must use BizTalk Server, or anything like that. There are implementations of patterns, and for example, the well-known Design Patterns book, which I'll be showing you shortly, there was a Visual Studio add-in where you could basically dial up, I want a command pattern, and it would generate the classes for you and do that kind of thing. But the pattern themselves are not an implementation. So patterns started in IT with some initial work by Kent Beck, He presented at the Object-Oriented Conference, OOPSLA conference, and then a bunch of patent literature came out. So there are the Design Patterns book, the Gang of Four book, which is the one that you see at the top, partly hidden on the left-hand side. It's called the Gang of Four book after the four authors. And the Integration Patterns book by Gregor Hope. They were kind of seminal works in the area. Microsoft has contributed with, there's two of the books from Microsoft there, but there's also an Enterprise Application Patterns book, several other patterns books, and there are websites dedicated to the different patterns. Patterns literature tends to vary in the way they describe patterns, but there are some common contexts to it. So there's a pattern name. When you start building patterns in a new area, typically people argue about the names, but after a while those names stabilize out. So if I talk about a chain of responsibility pattern, that's a pretty common pattern description, and anybody that's worked with patterns will know immediately what I mean. Similarly with a command pattern. There's usually a short paragraph in the pattern description about the intent. What problem is this pattern designed to solve? And then there's motivation, or sometimes called forces. They're what's driving you towards this particular pattern. And then there's usually a few graphs or pictures to give you some idea of the interrelationship of the objects that make up that pattern. So if I talk about, again, a chain of responsibility pattern, that's typically a pattern where I have a number of objects that want to act on some information. And the information's passed from object to object to object. So that's the kind of description. So if you look at the books that were on the previous slide, you'll see most patterns are introduced roughly in that way. Now, when I start modeling about my enterprise, remember I'm looking at an insurance company or a bank. I look at the overall, I have a business problem to solve. One of the capabilities that was identified in yesterday's talk, for example, and I need to start by looking at it from a business architecture point of view first. So we look at, this is the enterprise architecture kind of stuff. We start by looking at it from a business architecture point of view. That's typically done by, the stakeholders, the people that run the business. And then we start looking at it across the applications and services that we already have available and how we're going to integrate those. So we're talking about integration architecture and the pieces that we need to build, which is, of course, the application architecture. This talk won't cover operational architecture and development architecture, but potentially those could be areas of interest for you as well. So each of these, the integration architecture and the application architecture, has a cluster, if you like, of patterns with relationships between them. And for each one of them, so for example, just looking at integration architecture, we have patterns at different levels within that as well. So we have patterns at the level of architecture. So you probably wouldn't be too surprised to hear that, for example, service-oriented architecture, people will immediately turn around and say, you need an SOA. That's an architectural level pattern. Architectural level patterns aren't designed to be implemented. They're just designed to guide you to the next layer, which is the design patterns, which is how do you implement your service-oriented architecture? And then there's the actual implementation, which is talking about WCF or things like that. But there are specific patterns around the implementation as well. So things like publish subscribe as a pattern tells you how you're going to implement the movement of messages around your services and so on. So, as I said, patterns exist in a hierarchy. If we look at just implementation patterns, then at the uppermost level of integration patterns, we have integration at different levels. We have integration at the portal, so that's your SharePoint site or your ordinary website. You have integration at the process level. So that's the actual business processes, integrating several business processes together to create a new composite business process. And of course, we have integration at the data level, the entity level. Stepping down into the design patterns, we could look at message-oriented middleware. We could look at a service-oriented integration. We could look at sharing databases, data synchronization. Those are different levels at the design level. And then at the implementation level, we look at, are we going to use a message bus or a message broker? I'm not going to go into, until later anyway, go into detail for each of these, but this gives you a traceable view through your system so that you can decide which patterns suit your particular enterprise. So as I said, patterns and layers, we can look at integration at the portal, we can look at integration at the process level, and we can look at integration at the entity level. So industry's been using pattern-based design for decades. Automobiles and aircraft are one example, and machine tools are another. And applying these patterns in the same way to our software development, particularly our enterprise software development, gives some good benefits in terms of predictability, because we know in a more concrete way what we're going to build, and what's more, the team has a common understanding of what we're going to build. We can mitigate risk, and we can increase the productivity of the whole team, because often you'll find that a pattern will recur several times in the design. But the other thing to remember is they're not a magic bullet. Just like saying I'm going to apply service-oriented architecture is not a magic bullet. You can use really known good mechanisms to build planes that don't fly and applications that don't scale. And I'm sure we've all come across situations of the latter. So apply patterns when they're relevant, and then make sure that you iterate through the design. Don't jump straight to the answer or the final iteration. You need to start at a higher level and then iterate down. And you should see that in a moment or two when I start designing the first example. Now, I'm just going to very quickly skip over these slides because I'm sure I wouldn't do them the same justice that Parley did. But Parley talks about capabilities in an organization. And it's basically, for us, it decides what are we going to build. Now, once we decide what we're going to build, then we've got some hope of being able to go ahead, get projects started, get funding, and go ahead and start designing it. And this is a slide I gratuitously stole from Parley's deck. So he's basically gone through and given an example of some high-level capabilities that exist in the banking world. The examples I'm going to use are, there's two examples. This is the first one. This is around one touch and one customer view. So the example is a insurance company that basically has a number of different applications that they maintain their customer information in. And so if I ring them up and I say, hi, I'd like to change my address, they have to currently go through multiple systems, basically typing in the information. One of the Microsoft guys that was working on the patterns book with me called it swivel chair integration. They're sitting one side typing stuff in, they swivel on their chair and type in stuff the other side. Now, you might think this is a bit of a trite example, but there's at least one enterprise in New Zealand, and I guarantee there's more, that hires people on a full-time basis to do nothing but change personal customer information in multiple systems manually. So this is a real example. Note, I'm being careful not to say who. So some complexities with doing this. So we want to do two things here. Firstly, we want to get an aggregated view of customer information from, let's say, 4 systems and have them displayed on screen. And the other part of the puzzle is we want to then be able to change that information and make sure it goes, exactly the same information goes to 4 different screens. Because you can guarantee once we put the solution in place that initially we're going to get a lot of completely different results back. I mean, if you have people manually changing information in 4 different places, there's bound to be errors in some of them. So, some complexities with the overall solution. Firstly, the whole capability is the aggregation of multiple simple business services. So we have 4 simple business services available. I mean, they may not be readily available, but they're available. We can change account information in each of the systems. Some of the systems are inherently asynchronous. Mainframes are a notable example and usually cannot be left out of the equation. They're kind of the sacred cow of financial services institutions. So often the connection or the gateway that you use to get to your mainframe from say, the PC world is inherently asynchronous. We may also need to execute business rules, and more about that afterwards. And you might think, well, why do you need to execute business rules just to change an address? But I'll cover that shortly. And we may require transactional logic, or if we can't use real transactions, we may need to provide what's been come to be known in the industry as long-running transactions. That is to say, transactions that provide their own compensation. Because we don't want to continue to be in the situation where if I try to change an address in one place and that fails, I just go ahead and I change it in the other places and let that work. I need to be able to roll back the whole transaction, even if it isn't a transactional resource. And some of them will have complex integration requirements. By that I mean the way we get to those systems might involve screen scraping, things like that. So, starting at the high-level architectural patterns, just viewing the address information seems like a pretty straightforward case of using portal integration. And for now, I'm skipping over exactly how we connect to the database, the mainframe, and the CRM. I'm just assuming that I'm going to. And for updating the address information, I'm going to need process integration. Why do I need process integration instead of just calling a bunch of functions? Well, there's a couple of reasons. The first reason was around what I've already covered. That is that it's very unlikely that all 3 of those will actually take part in a real transaction. The database almost certainly will, but the others won't. They won't adhere to the XA compliant transaction protocol, which means I can't just go commit or roll back. So I need to provide some kind of process in place to be able to compensate when things go wrong. So the classic example is the database would commit, the mainframe might commit, and then the CRM system says, no, I can't make that change for whatever reason. I have to roll back the other transactions, but I can't roll them back because they've already been committed, so I have to compensate. Essentially, I have to undo them manually. The other reason is that for using process integration is that I probably will need to execute a process. Why? Well, let's say the scenario is that you have both household contents, household and car insurance with this insurance company, and you shift from a affluent, well-to-do suburb with a relatively low crime rate to another suburb which has a high crime rate. Your insurance premiums are going to change just as a result of your changing addresses. And that will be a process that will run on the mainframe, typically. So, I'm now refining down to the design patterns. Hopefully, can you all see that reasonably clearly at the back? Great. The trouble with drawing these is you get to some fairly large bits of paper. I've also added, you can see a financials column there. So the first thing I did when I started to put this together was, or when I started to design this was, I started looking at how am I going to integrate. Now there's a variety of different possibilities for integrating. I've chosen in this particular case to use presentation integration, which means screen scraping off a green screen. There are obviously other ways to get into a mainframe, but just for the sake of this example, that's what we're using. We're using functional integration to get into the CRM. data integration into the database, and functional integration again into the financial system. The first bit of refinement to my design was I then put a service-oriented interface across the top of those integration points. The reason for that is that I anticipate that we'll need to do more and more integration as new capabilities are developed, and providing a uniform service-oriented interface to this makes the whole system much easier to develop. The other aspect is that it means that everything that happens outside of that service-oriented interface can now go down to a set of common schemas, which provides some good benefits later on. You're not constantly having to remap and everything. And we still have our process integration and our portal integration. These two separate use cases are essentially the same design though, and you'll see shortly we'll merge them. So if we go ahead and look at just the customer lookup, I want to do a little more refinement, if you like, about this. So the next refinement that I decided to come up with, or that I came up with for this was, I now have 4 endpoints, 4 service-oriented interfaces, and they could be web services, they could be a different kind of service, they could be a functional service using something like Unity in Enterprise Library. In fact, I did one over in Australia where we connected to the mainframe using MQ series, which then connected to an MQ series CICS bridge, and that was still implemented as a service with a service-oriented interface on the front of that. Now, the first refinement, or the next refinement rather, that I decided to do was, well, okay, so I've got 4 different systems. I could hard code, send a message to that one, send a message to that one, send a message to that one. But it would be much better to use some kind of message broker or message bus. So in this particular case, it's arguable which would be better, message broker or message bus. It's probably going to be driven by the technology that you've got available. A message broker pattern involves a centralized broker of information. All of the people that send messages send them to the broker, and the broker is responsible for passing them on to the end systems. A message bus is slightly different. It connects all the different systems, and they have adapters on that connect each system to the bus. And basically, you throw all the messages on the bus, and anybody that's interested in a particular message grabs that message. The main difference between the two is that a bus tends to require all the messages to be the same format in the bus, whereas a broker, all different kinds of messages can be passed on. So in this particular case, I chose message broker. And as a slight refinement to that, I decided to add the publish subscribe pattern to it, because now I can send a single message, change address, to the message broker, and then the message broker, using publish subscribe, will decide which systems to send it to. Why? Well, let's imagine that next year we acquire another insurance company or another bank, and we end up with 4 more systems to add on the end. We don't want to have to change our code. All we want to do is change the subscriptions to the message. So that's why that was put in place. Okay, and now I'm going to merge my 2 use cases. So ignoring the half sync, half async for a moment, we have portal integration and process integration together, talking to a message broker which uses publish subscribe and then passes the messages on to a bunch of service interfaces which then talk to the integration points to the mainframe and the CRM database and the financials. We also need to introduce asynchronous messaging. And asynchronous messaging becomes essential, especially when you're talking to legacy systems or talking to systems that will some of the time require human input. You know, you might have a human workflow system in the middle of it. You require a result from somebody else. Now, of course, if we want to display our information on a portal, then an asynchronous process in the middle of our enterprise causes all kinds of issues, because people don't want to sit there and look at a page and wait. Well, let's face it, the web's several times out before you get a reply from some of the systems that are in, banks and insurance companies. So there's a pattern has been designed to answer this, and basically the way it works is it links two asynchronous operations so that you can get a synchronous result. Basically, I ask the system that I'm talking to do something, and it issues a ticket. It says, okay, loan approval is a great example. Okay, you've given me all the information for the loan approval. Your loan approval number is 1. And sometime later on, I come back in and I give it the loan approval number 1, and it sends back the results. And we'll see that pattern come up again shortly. So that's the reason for the half sync, half async. It's basically a way of programming around the asynchronous nature of the enterprise so that we can present it in a reasonable way, for a synchronous website or a synchronous application. Just as an aside, we also often add, this is a good time to add something like business rules to your application so that you can be as sure as possible that that loan application is likely to succeed by checking as much of it as you can in a synchronous way before you let the asynchronous parts of it carry on. Now, once I've put those patterns together, and that's kind of the end of my pattern-based part of the design. As I said before, the patterns give us the capability of talking about it in a cohesive way across the whole design team. So I can say to the design team, okay, we're implementing this part of it as a message broker with publish subscribe. And they can go ahead and they know exactly what it is that they're going to build. The other aspect is we can then lay that onto technology. Now, obviously, it isn't the only thing that decides what technology you use, but it allows you to start thinking about the kind of technology you might want to use. So, as I said, a pattern isn't an implementation and doesn't require you to use a specific technology from Microsoft, but it can. If we imagine that our organisation is Microsoft-centric in this particular case, then the message broker technology, the half sync, half async, the process integration, and all the publish subscribe quite naturally fall into the BizTalk server world. Although after a presentation I saw yesterday, maybe now they fall into a workflow and other world. But you get the idea. You can start laying down specific technology against these things. The SOI, obviously, we're starting to talk. The BizTalk server, WCF adapters, or WCF itself, and the presentation integration, the screen scraping, and so on. So you can put your favorite technologies against that. And of course, you can also, hopefully, align it to technologies that you already possess in the enterprise. So let's have a look at another capability to design. And this time we're going to do a somewhat more complex one. I'm not going to go through all of the individual steps. I'm going to present the overall design and then just talk through some of the aspects of that. So in this particular case, we're talking about self-service. So we're talking about a bank coming in and putting together a page where a user can basically pay various bills in that, in particular bills for loans that they have. And this is the example out of the patterns book. So we actually implemented all of we designed it first, and then we implemented all of these patterns in a lab and sat there and stressed them, put load on them, all that kind of stuff. Again, we have some complexities. Some services are external to our enterprise. So in the previous example, all services were internal. Now some services are external to the enterprise. Some services are asynchronous. We may require business rules to be executed, and we almost certainly will require transactional logic and compensation. So, and we have some complex integration requirements. So these are the issues. The business process is basically, okay, obviously log in, get the existing financial position of the customer. That means going out and getting his account balances, getting his, you get the customer profile, their account balances, any existing loans they have, and get a list of the scheduled payments that already exist, combine that information, display it, and then allow them to create new scheduled payments. I'm not going to cover the create new scheduled payments. I'm just going to look simply at the getting the list of scheduled payments. So we have a number of different applications. We have a web app that we're going to build. We have an external broker that has loans that potentially this person has and has already got payments going to. We have the mainframe, which has the payment services. It has the account number and so on. Customer profile is in some kind of, probably some kind of CRM system. We have the account balances, and of course we have something like an Active Directory in order for them to manage the login process and so on. So the patterns that I came up, or the pattern design that we came up with, was the following. So I'll try and talk you through the various reasons and logic for it. Once again, we have a portal integration. We have a bunch of information coming to the portal. In terms of development of the portal, we decided we'd use MVVM, model view model design pattern for displaying that portal. We have our database, our CRM system, and our account services, data integration to the database, services interface to CRM, possibly MSCRM. We have service-oriented interfaces on the front of that. The account services is shown as an integration using a gateway. A gateway is a design pattern for when you are basically talking to an external system or systems where there is a single interface to that. So some of the mainframe technologies, there's a single interface through to the mainframe, and so we think about that as a gateway. And then we have some external loan services where we have to go out and we have to ask them, does this person have a loan with you? That's one of the areas of major asynchronicity. Those loan services are outside the context of our enterprise. We have no control over their quality of service, the level of service that we're going to expect from them. They may or may not reply. And then we have our external partners when we're actually setting up the payments. We have an external partner, which is a SWIFT partner, and we have an external partner, which is a manual partner, which means we're sending information to an external agency that prints a check and sends it to that person because they don't have facilities to handle SWIFT transactions. And once again, we have service-oriented interfaces across the front of these. So when you first start to design this, of course, somebody's going to come out and say, yeah, looks like an SOA to me. Well, thanks very much, but you need a lot more detail to be able to go and implement. You can't just say SOA. SOA is at the high level of that design. It's not designed to be implemented directly. You need to drill down, and that's what this starts to do. So I've now got service-oriented interfaces, and I know how I'm going to connect to my different systems. The next step, as in the previous example, is that I'm going to use a message broker to send the information to the appropriate systems. And then that way I can use publish subscribe to connect to those systems. I also have process integration because, of course, in order to do the previous example, hang on, I'll just see if I... In order to step through the sequence, we want some kind of process engine to manage this whole process and handle situations where failures occur, handle compensation for transactions that fail. So we can, of course, use standard code for the process integration part, but there are big advantages to using some kind of process engine, like BizTalk, like Windows Workflow Foundation, like multiple other tools that are out there. These give you a lot of advantages in terms of handling long-running transactions, handling correlation, so that when messages come into they come into the right version of the right process. They give you other advantages in that the process and the implementation are loosely coupled, which means that if for some reason you decide to change one of the processes here, or one of the connections here, you can change that connection without changing the actual process itself. You only change the actual activity, if you like, or actual step in that process. And the other benefit of process integration around the long-running transactions and exception handling and the management of that process for what could potentially be quite a long-running transaction. This first half of my business process is probably pretty quick. At least we hope that the external loan services will reply in a reasonable period of time. But other processes in banks, like for example loan provisioning, where we have to go through a number of steps and analyse things, or in insurance, where you might be doing an insurance policy, trying to set up an insurance policy, you have to run quite long processes that might run over days. And so one of the insurance companies here in Auckland implemented such a process for external brokers to be able to use the website to go through and put in a new insurance policy. And that process takes a few days to run. And the process integration, when it's managed by a process engine or a process manager like BizTalk Orchestration, automatically takes care of catching all the incoming messages intended for it. That's correlation. It manages the long-running transactions, and it manages its own state and manages to not consume system resources when not necessary. So those process engines typically will crystallize or store all the state into a database and then reactivate that state at a point in time when some more work needs to be done. So lots of benefits from using those. Now, once again, we can get a baseline implementation, and I apologise, this is probably my least clear slide. We can once again get some implementation details in terms of the kinds of technologies that we'll use. I didn't fill this out completely because the slide was busy enough, but obviously the data integration, the service interface, the gateway might have been host integration server, those kinds of technologies. So you can basically map each of the patterns, each of the pieces you need to implement in terms of specific technologies. Once again, BizTalk's come into the middle here. Obviously, I work with BizTalk a bit, so I tend to think about that one. And then once I've put those together, I can even put together a baseline deployment from the patterns. So I know the things that the different things I need to build. I know that I've got an integration server somewhere. I know that email wasn't actually part of that design, but is actually part of the overall design. There's a web server. We have additional integration server requirements, probably outside our corporate network, because this is talking now to our external banks. We have requirements for CRM and so on. And we can map as many of those, hopefully. We can map those onto existing corporate assets. Certainly the CRM, the directory services, the payment, the gateway services, they're probably already available, even if you don't have the integration server. So you can map those and get as an efficient mapping as possible for your solution onto the existing corporate space. Patterns in other places. So this is kind of my last little slide in this talk, and this is really about where else are we using patterns. So having now done an architecture and a design, we now need to implement. and you'll see that particularly if you read the Gang of Four book, there are a lot of code patterns as well. So these are patterns around implementation. And I've just chosen this one quite at random. This is Prism. So Prism is a guide for building composite applications. And it also uses a whole bunch of patterns, this time at the development level, for implementing these kinds of applications. So for example, if you're building your portal, you would use something like Prism to do an MVVM style portal, and you'd use other patterns inside Prism, like the Unity application block for providing services. So this is a kind of a service locator pattern, aggregation of events, a command pattern, and so on. So basically, your whole application from the very top level architecture can be designed in patterns, in layers, and iteratively gone over to refine it until finally you come out with some specific chunks of implementable work. And those specific chunks are well designed and well understood because the patterns do most of the documentation of those individual pieces for you. Just to finish off, the other aspect of this that doesn't quite fit into the level of patterns is, and in the books they often call them patlets, which I absolutely abhor as a term. I much prefer heuristics. So heuristics are some guidelines for some good ideas when you're doing this stuff. So you'll have seen in my previous designs there were quite a few places where I had service-oriented integration. And essentially what I was doing was I was layering services around the outside of my, I'll call them legacy systems. Some of them obviously aren't true legacy systems, but my existing systems. And then I want to go ahead and basically orchestrate and process manage my new business capabilities in terms of the existing business capabilities that are already there. Now, when you do that, of course, and this is the classic service-oriented architecture pitch, you need to start designing those interfaces. So just some rules, if you like, that I've observed over my time in doing this over the last 5 to 8 years. When you're building those interfaces, firstly, make those interfaces as simple as possible. Those interfaces, everybody always asks me, what granularity should I make my interfaces? Well, it's a hard question to come up with an absolute answer, but my answer is make them a single piece of business logic. So if the business logic is update customer account or update customer account details, that's a service. That's an interface for a service. Updating his address is not. It's too granular. And if you make the service interfaces, too coarsely granular, then you'll find you have difficulty composing them to create new business processes. But on the other hand, if you make them too fine-grained, you'll find your applications are relatively inefficient. So to give you an example, we were building the teller applications for Commonwealth Bank, and the developers that were building the teller application were fairly experienced in the situation where your database was sitting beside you. They were used to building client-server apps using things like VB6 and Delphi and whatever your favorite application is for that space. We introduced them the concept of services. They thought they were wonderful, and we built, we started to build the services they wanted. And everything was going well until somebody took one of these teller applications out to Perth, which is, 3 time zones away from Sydney, and they connected it up, and it took a minute and a half for the front screen to load, because these guys were going out and getting finite, tiny pieces of information at a time. They then decided they'd try basically sending multiple requests at once, which made things faster, but still didn't really solve the problem. They'd gone too granular. So the right granularity, as I said, is for me is achieve one piece of business functionality at a time. Update the whole account. Don't update one line at a time. Obviously conform to whatever standards. In the case of web services, that's WSI. In the case of MQ series, as in the example I gave before, obviously there are standards there too. Make it easy to version if you can. Provide the capability of adding additional parameters. So there are white papers on Microsoft and on IBM's website on how to build extensible schemas. And the other thing is compose your schemas as families of canonical schemas. A canonical schema means it shares a common definition. So an address is a good example. In New Zealand, we have typically three kinds of addresses. We have, city addresses, we have post box addresses, and we have rural addresses. So design an address schema that allows you to cater to all of those, and then use that schema throughout your enterprise. So you publish it as a chunk, if you like, of schema, and then you reference that chunk in every schema that you build. It saves a heck of a lot of mapping and a heck of a lot of code once you start building more and more services. And obviously, try to make the interfaces loosely coupled. And one last set. When you're building your services, build a set of common services that are shared by all of your applications. So these are things like security. How do you do your, or come up with a standard way for doing your authentication, your authorization, your encryption. Also come up with a standard way for doing your enterprise-wide logging, auditing, that kind of thing. Those kinds of services are often built using another pattern, a change of responsibility pattern, or a pipeline as they're often implemented. And if you look at WCF, that's built in for you. WCF has an inbound pipeline and an outbound pipeline for the requests. Once you start to expose your enterprise's services, then you need to compose multiple services into new business processes. That's when the business starts to see benefit from the work that you've been doing. When you first stick a service on the front of an existing system, most of the business will say, yes, so what? But once you can start to compose them and build new services in a rapid way, then they'll start to pay attention. I've already talked about Process Manager. The other one is deal with failure. Hand off to humans. Don't spend so much time on a business process. If you're taking a totally manual business process, chances are you'll only get a 90% or so fit to a smoothly running automated process. 10% of the time will be exception conditions. That's okay. You can hand those off to humans. They can take some corrective action and then make sure that you hand it back to the original process so that the original process can continue. So loan origination is an example. There's always boundary conditions that need to go to a human advisor. He uses his capabilities that you just simply cannot program in to make the appropriate changes to fix the problem and then realign it to the original business process. That's it. Thank you very much for listening.